Hello, dear college. The title of my article, The Assessment of the Process of Drawing of Cylindrical Workpiece Without Pressing with Alternative Strain of the Workpiece Flange. Authors Roman Arhat, Viktor Shchetynin, Ruslan Puzyr, Dmitry Savelov, and Tetiana Haikova, with Kremenchuk, Mikhail Astrogatsky, National University, Ukraine. So, method of manufacturing cylindrical parts by drawing in the cold state and use it at almost all mechanical engineering enterprises, which include forging and workpiece reparation, workshop, and section. In large-scale production, rather productive drawing methods are mainly used, such as drawing with pressing the flange, these pulling ribs and seals, drawing at sheet stamping machines, drawing out from a tape, drawing with thinning the wall, etc. In single and small scale production, the use of most of the above methods is practical due to the high cost and the duration of the die tooling manufacture, the use of multi-operation, which makes it difficult or most impossible to reach to the production and development of products new types. The decisive role here will be played by partially universal or universal equipment, which can be used at any stage of manufacturing a new product. From this point of view, the application of the non-pressing method is single and small-scale production is promising and low cost. Hence, there is a need to complicate the equipment by the feed-ring and use double and triple action process. Therefore, the purpose of the work consists in the experimental research of the possibilities of the drawing method with alternating strain of the flange and the development of the recommendation for production. Drawing without a fault holder for flanges parts is only possible with a low drawing coefficient 0.75, 0.85. To implement this process, simple equipment is used, where the stamped patterns mainly pull it to deep. It is difficult to turn a flat part into a hollow one. The process is accompanied by the formation of an insignificant amount of folds and their smoothing, then pulling the cup through the gap between the die and the punch. Moreover, parts made of plastic metals and alloy with a large flange can be drawn without noticeable signs of corrugation without pressing, only to a shallow depth, h equally 3 to 6 s. High values of h correspond to workpiece with big thickness. Drawing without pressing parts with big flange is only possible before the start of decreasing the size of the initial workpiece. To test the possibility of obtaining high-quality cylindrical parts by drawing without pressing the flange, experimental research which was carried out in round workpiece and various diameters and thickness. The process of drawing without a fault holder is accompanied by the difficulty of the centering the workpiece on the die, and as a result, unilateral training of the semi-finished product, the appearance of primitive faults and description of the location of strain, and these processes are aggravated when using the same die for workpiece of different diameters. Therefore, conduct the experiments of universal die with movable centering elements was designed with the help of which the workpiece was accurately aligned with the hole of the die and punch. Here, the clamps move along the radial grooves simultaneously and synchronously with each other to the center or from the center of the die, which ensures self-centering of the workpiece. After the first stage of drawing pasted, the semi-finished product with corrugation was removed from the die, turned by 180 degrees and reinstalled. It was centered with the use of moving elements. The stock of the punch was turned and the semi-finished product was deformed until the corrugation of the flange were smoothed out. The punch was stopped and it was given precisely calculated stroke until a new formation of folds of the infant's curvature on the flange. The length of the reverse stroke of the punch was calculated by mathematical dependence. Then the semi-finished product was removed from the die, turned over by 180 degrees, and the process was repeated until the decided product high was obtained. Thus, all batches of workpiece were drawn and their final height exceeded the standard height of the products obtained by drawing without pressing the flange and corresponded of the height of the drawing parts with the use of pressing. Slide 5 demonstrates drawing steps with the workpiece turning. Some results of the performed experimental research are present in table. The table demonstrated that it is possible to obtain the aluminum and steel parts after at least 6 turnings. The number of turnings depends on the workpiece diameter and the drawing coefficient. With the large diameter and the smaller the drawing coefficient, the greater number of the turning is necessary to obtain a normal part. Aluminum is more ductile metal in this case. In comparison with steel, it requires a small number of steps with the same initial parameters and drawing coefficient. However, the thickness of the workpiece is high for aluminum than for steel, which may explain the better stability of the workpiece flange and the possibility to obtain increased strain during one step. Drawing of the thin metal by this method is difficult because when the workpiece approaches the shape of the finished part, the corrugations are not completely smoothed out and remain on the product, which is unacceptable. Besides, the turning of the workpiece and the strain results in a loss of button stability in the form of the local buckling of metal. It is shown in the table for copper workpiece whose thickness is 0.25 millimeters. Thus, the conducted experiments confirmed the possibility of manufacturing cylindrical parts by drawing without pressing the workpiece flange with its step-by-step stretching. Thank you for attention.